Okay, Assalamualaikum and good morning, everyone.
Waalaikumsalam, Dokter.
Salah doktor.
Okay, so today we will continue with our class and we will discuss tutorial 1 regarding lecture 1, basic concept of control system. Okay, so let's look at, there are 3 questions, so let's look at the question one by one. Okay, question number 1, in a residential heating system, the indoor temperature is the response variable of interest and it is affected by the main disturbance input, which is the outdoor temperature. Figure 1 indicates the desired temperature, which is the command input temperature, is set on calibrated dial. This positions the valve that admits the steam for circulation through the radiator. The valve dial is calibrated when the environment temperature has certain value. When this value changes significantly, the control temperature will deviate from the desired value by a large error, and hence precise control will not be desired. So draw the block diagram of figure 1 when the performance requirements for heating of a residential building are not very stringent. Okay, so for this kind of question, you need to um, firstly identify what are the elements of control system. Okay, so the elements are given in the description and also in the figure. So firstly, it's better if you can identify what are the elements before you can draw the block diagram. Okay, so let's identify the elements. So the input will be the desired temperature that is controlled on this dial, calibrated dial. So you can put desired temperature, or you can put desired temperature controlled by dial, or input command input temperature, as long as there is the word temperature. Okay, and then the output will be the indoor temperature. So you control the temperature from the dial, and it will affect uh, the temperature inside the room. Okay, so the temperature inside the room is your output, okay, or the actual output. So the output is the room temperature or the indoor temperature. Okay, and then we have the plant. So the plant or process, so everything happens inside the room. Okay, so we can say the plant is the room. And then we have subsystem. So the other things are subsystem. So subsystems including the valve, radiator, that's it. Okay, valve and radiator are the subsystem. So to be more detailed, the valve is the controller, and the radiator is the actuator. Okay, so when we have identified all the components, then we can draw in the block diagram format. So you can start with, okay, firstly, we need to identify whether the system is open loop and closed loop. So there is no sensor that can provide feedback to the system. So when there is no sensor, meaning that the system is not closed loop. It is open loop. Okay, there is no sensor given in the figure or in the description. So there is no sensor, meaning that the system is open loop. So you need to draw a block diagram in a straight manner. Okay. So we can start with desired temperature. And then it will go to the valve. And then to the radiator. Then room. And then the room temperature. Okay, so this is the block diagram for the system in figure 1. Okay, if you have any question, just ask me, okay, and stop me at any time, okay. Yep.
Saya akan record session ni ke tak?
Ada record ni.
Okay.
Okay, so question B, asking you identify the system whether it is open loop or closed loop. So from the block diagram, it's an open loop system. So open loop. Oh, kita tinggal satu benda kat sini. Okay. So kita ada, we have the disturbance here. So we have disturbance from the environment. So just put disturbance, environment disturbance. Environment temperature. Okay. So usually when there is a another arrow coming into the block, when there are more than one arrow, so we use this circle with cross. Okay. So this circle with cross represent like summation. Okay, summation. One arrow from radiator and one arrow from environment temperature, and then becomes one arrow. These two sum plus together, added together, and then becomes one arrow coming into the room. Okay, so we use this circle with cross symbol. Okay, so back to the question B. So it's an open loop system. So open loop because we can say that there is no feedback. No feedback. Feedback loop that that compares the output with input temperature. Okay, so meaning that there is no feedback that can compare between the input and output temperature and do the correcting mechanism. Okay.
Tak ada feedback tu maksudnya dia tak ada sensor lah doktor kan?
Dia tak ada sensor, satu.
Jadi dia tak ada feedback, tak boleh nak
dia tak boleh nak compare input and output. Okay.
So dia macam mana? Boleh tak macam safe to assume tak kalau kita kata kalau tak ada sensor, kita assume dia open loop system?
Boleh, tapi kadang-kadang ada sensor tu dia sense macam antena, yang case antena minggu lepas, kita ada potentiometer yang measure input rotation dengan potentiometer yang measure antena punya rotation. So ada dua sensor kat situ. Sensor dekat input and sensor dekat output. So sometimes kita boleh ada dua sensor, tapi sensor ni dia measure input saja maybe. Satu lagi sensor measure output. So kalau tak ada sensor yang measure output, tapi ada sensor yang measure input saja, it's still open loop lah. Maksudnya dia tak measure anything from the output. So if you don't have some measurement of the output, then it's an open loop system. So sensor tu kadang-kadang mungkin dia mungkin soalan tricky ke, let's say lah ada soalan tricky ke, dia letak sensor dekat input tapi dia tak letak sensor dekat output. So dia tak measure output, dia measure input punya values je, punya variables je. So it's still open loop but not closed loop sebab dia tak measure output tadi. Okay, it was a good question. Okay, now let's look at question C. So design another block diagram if the system is converted to a closed loop system by adding the function of measurement of the controlled temperature and comparison of measured and desired value of the controlled temperature and control logic to make changes in the heating rate when the desired and measured values differ. Okay, so question C dia dah bagi tahu dah buat closed loop and add three things. Okay, so firstly you need to add some measurement of controlled temperature, and then secondly add something that can do comparison between the input and output, and lastly add a control logic. Okay, so you must add these three things. Okay, so if you don't add these three things or you miss one of the things, so markah tak lengkap lah. Okay, so basically question C you just modified from figure question A that you have drawn, the block diagram that you have drawn. Okay, so draw baru lah. Okay, so so firstly we have the desired temperature. So the desired temperature, and then this for a closed loop, you must have this circle with cross. Okay, after input lah, usually after input. Okay, so this is our input, and then we have this circle with cross. So this circle with cross is actually the second item here, the comparison of measured and desired values. Okay, so this circle with cross, later maybe week 4, week 5, we will learn more about this. Okay, but the function is to compare the measured and desired values. And then after you compare, then you must do some calculation. Okay, or the system must do some calculation. So usually we will have a controller right after the comparison symbol here. So just put here control logic. And then followed by valve. And then radiator. And then we have another circle with cross due to the disturbance. Okay, lukisan saya bengit dan korang lukis cantik. Okay. And then our room, and then the room temperature. And then the question also asks you to add function of measurement of controlled temperature. So meaning that the question asks you to add a sensor. So preferably if you can name a sensor that can measure temperature or measure something, is better, okay? Instead of just putting the word sensor. So in this case, we can put a thermometer ke? Thermometer, because thermometer can measure the temperature. Okay, so the arrow will start here, meaning that it measures the room temperature. The thermometer measures the room temperature, and then another arrow will go into this comparator. Okay, the close circle with cross. Okay, so if you have all this component, sensor and also a controller, so your answer for question C is complete. Okay. Okay, any question before we proceed?
Sir.
Sir,
Circle with cross tu dia biasanya memang sebelum lepas design input lepas input tu kan sir.
Yes, usually after input, when you want to draw lah, okay. But later ada chapter about block diagram reduction. Usually they can be anywhere. It can be anywhere. But for drawing block diagram from nothing, usually we put it right after input.
Thank you sir.
All right. Okay, so let's look at question number 2. So question number 2, the open loop TCFI system has inputs for RPM, throttle position, and cold start related variables. Fuel lookup table translate this input into predetermined fuel injector pass width. The fuel injector then deliver fuel to the engine. The overall accuracy of the system is dependent on the lookup table and the fuel injector. If the lookup tables are not correct or the fuel injector becomes clogged with deposits over time, engine operation will suffer. Okay. With a closed loop fuel control system, a feedback path is added to allow the system to make correction. In the case of the TCFI system, wideband oxygen sensor measure the actual engine air to fuel ratio. The system compare the AFR command from the fuel table to the measured AFR from the sensors. The difference between AFR command and the measured AFR is referred to as the AFR error. The system slowly makes corrections to the injector pulse width to drive the AFR error to 0. These corrections are stored in block learn multiplier table organized into RPM TPS cell. BLM table is continually updated. When engine operation shifts to a new cell, the system can use the BLM value last saved in this cell as a starting point for further correction. Over time, the system will learn the BLM value required for every cell in order to drive the FR to error to 0. Panjang gila. This process is referred to as auto-tuning. Based on explanation, draw the open and closed loop block diagram. Tiba suruh draw. Okay, so there are two things we need to draw, open loop and closed loop system. So let's draw the open loop first, okay? Main sangat. Kita relax dulu. Kita tengok dulu. Okay, so the first part here that I put garisan here is actually the open loop, okay? Dia panjang dia open loop. And then second one is the closed loop system, okay? So let's look at the open loop system. So as similar to question 1, we identify the components or the elements of the control system. Okay, so let's identify the input. So input. So here the inputs, the S, okay, inputs. So ada banyak input. So we have RPM, we have throttle positions, and we have cold start related variables. So there are 3 inputs. Okay. So we have RPM, we have TPS, and we have cold start variables. And then let's look for the output. And then the fuel lookup tables translate these inputs into a predetermined fuel injector pass width. The fuel injector then deliver fuel to the engine. The overall accuracy of the system is dependent on the lookup table and the fuel injector. If the lookup tables are not correct or the fuel injector becomes clogged with deposits over time, engine operation will suffer. Okay, so dia punya output dia tak berapa clear or not very direct. Okay, so it's about engine. So if we have this input, and then the output will be the performance of the engine. Okay, but later in the closed loop system, the output will be the engine air fuel ratio. But in the first section, I think the output will be either the engine operation or the engine performance or the engine accuracy. It's about the engine, okay? So you can write engine performance, for example. And then we have plant. So plant. So here everything happens in the engine, okay? And then subsystem. So here we have this lookup tables. So all of the inputs will go into the lookup tables to produce this fuel injector pulse width. Okay, so we have lookup table. And then translate into fuel injector pulse width. And then fuel injector deliver fuel to engine. So we have fuel injector here. So it becomes fuel injector pulse width and then goes into fuel injector.
Doktor.
Okay. Yep.
Kalau untuk output tu dia macam boleh macam-macam parameter kita boleh letak kan.
Tapi
Sebab
dalam
kalau
question
tengok kat sini, dia ada cold start related. Maksudnya kalaunya cold start dia untuk performance pada waktu pagi lah. Maksudnya dia idling. Maksudnya mungkin output boleh jadi idling ke doktor? Idling operation ke? Ke ada jawapan yang kita perlu?
Tanya pasal kereta saya tak tahulah. Cold start variable pun apa saya tak tahu. Terus kan.
Okay.
Tapi sebab dia tak bagi tahu pun, tapi selalunya jawapan dia direct dari description je. So if you think your answer tu macam spesifik sangat, entahlah, saya pun tak tahu. Tapi dalam ni macam engine performance, in the end dia akan measure engine performance kan. Macam tadi awak cakap apa tadi? Lupa dah.
Idling.
Tapi itu untuk cold start variables je kan, macam RPM, TPS. Tahu? In the end yang tiga-tiga ni akan affect the engine kan. Entahlah.
Kalau ada jawapan yang berbeza macam mana doktor? Dia ada apa kata apa?
Skema macam tu ke?
Ada skema ke macam mana?
Selalunya contohnya macam soalan, let's say question ask you to identify identify a suitable sensor, for example. So contohnya suitable sensor for temperature measurement. So jawapan dia mungkinlah thermometer ataupun temperature sensor. Kalau suddenly you jawab sensor untuk temperature ialah potentiometer, memang definitely salah. So dia tak ada jawapan spesifik unless macam contohnya plant, awak pergi jawab plant ni ialah RPM is the plant, tu memang salah. Ataupun input RPM TPS tertinggal satu tu still acceptable lah, maybe minus half marks ke macam tu kot.
Yang bersesuaian doktor. Okay.
Betul.
Baik doktor.
Okay, so we have all of these components, then we can draw the block diagram. So we have RPM, we have TPS, and we have cold start variable. So ada tiga input, and then all of them will go into this cross circle with cross. Maksudnya dia effect dia orang tu akan ditambahkan, okay? And then all of this will be given to the lookup table. And then we'll go to the fuel injector. and then to the engine. And then lastly, engine performance. Okay. Actually soalan ni I think it was taken from a website. So if you copy this maybe sampai sini in Google, you can actually get to the website. Okay? And then in the website, they explain in more detail lah. Macam tadi lah, cold start variable, ada if dia memang explain detail, tapi saya tak baca. Block diagram dia pun mungkin slightly different from mine, okay. But since the question, the answer, your answer most probably not similar to the one in the website. So kita hanya kita akan tengok lah jawapan. Kalau macam logik, okay lah. Tak logik, tiba-tiba cold start dekat sebelah engine ke, itu entah boleh repeat ke.
Salah tu dah.
Repeat. Okay, and then next we have the closed loop section. So with a closed loop fuel control system, so a feedback path is added to allow the system to make correction. So dia dah beritahu dah ada feedback. And then in the case of the TCFI, so in the case of this system, so we have wideband oxygen sensor that measure the actual engine air fuel ratio. So kita ada additional system or additional subsystem known as the wideband oxygen sensor. And then the system compares the AFR. Tulis dah pening. So and then system compares the AFR command from the fuel table to the measured AFR from the sensor, which is this wideband oxygen sensor. The difference between AFR command and the measured AFR is referred to as the AFR error. The system slowly makes correction to the injector pulse width to drive this AFR to 0. These corrections are stored in a block learn multiplier table. So instead of using lookup table, they use this BLM table. So ada new subsystem. BLM table. So similar tapi dia BLM table, tak tahu kenapa. The BLM table is continually updated when engine, also mungkin lookup table ni tak updated. So BLM table is like automatically updated. Can be used the BLM value last saved in this cell as starting point for further correction. Over time, the system will learn BLM value required. So auto tuning, also macam auto tuning lah. So we have two things, wideband oxygen sensor and then AFR. Okay, so tulis je lah sini AFR. Okay, so for a more correct answer, boleh Google. Okay? So here we can try draw the block diagram. So we have RPM, TPS, and cold start variable. Okay, selalunya tulisan saya tak seburuk ni, tapi sebab dia pakai ni kan, dia jadi tak cantik.
Tulisan doktor.
And then we have BLM table. Okay, so based on the description, it says this correction are stored in BLM table. So maksudnya feedback loop dia dengan input perform will go to this circle with cross, measure the error, and then go into this BLM table. Okay, and then after that BLM table will Cost the, can use the BLM table. Last save, okay, dia akan pergi ke fuel injector. Ada benda lain tak sebelum tu? Tak ada, okay. So fuel injector. And then engine. So somewhere there will be this AFR, okay. Maybe here go AFR. And then we have the engine performance here. And then we have this at the feedback, we have wideband oxygen sensor. Okay, so the wideband oxygen sensor will measure the AFR. So maybe here. And then do comparison with the input. Okay. Nak letak sini pun boleh. Okay, asalkan ada rupa lah. Okay. So the second part, the closed loop, is something like this. Okay. So so now I hope you understand that open loop is always in a straight form, straight block diagram configuration. While for closed loop system, we have a feedback, a sensor, and a comparator or a circle with cross. And then usually followed by an additional controller. Okay. So if the question doesn't give any additional controller, so you don't add. But so far 2 questions already gave controller, additional controller to the system. So in this case, we have BLM table as additional controller. Okay. Any question before we go to question number 3? Okay. So now let's look at question number 3. A schematic for a car cruise control system is given in figure 2A. So question A, complete the block diagram in figure 2B by identifying each of the components. Okay. So here we have desired speed. And then we go into this control device. So what do you think from this figure, figure A, is the control device?
Electronic betul?
Electronic unit.
Electronic unit.
Salah.
Throttle pedal.
Throttle pedal.
Yeah, pedal. Okay. So the electronic unit sama macam last week saya cakap, dia macam powered, only powered the system, power the pedal, power the maybe electronics dalam tu. So dia tak control the things, okay? Dia hanya memberi kuasa je, okay? Memberi power saja. So anything that provide powers is not part of the control system. So things yang part of the control system is actually things yang kawal speed ke, kawal the control system, okay? So the control device is actually the throttle pedal or the pedal. Okay, because car cruise control system, car cruise control basically you nak control dia punya speed of the tire, okay? So kita control speed of the tire using the pedal. Means manual control lah. Kita control pakai pedal je. Okay, and then second block is actuator. So what do you think is the actuator?
Engine.
Engine.
Okay, bagus, boleh lah. Boleh lulus soalan 1. Okay, so the actuator is the engine. So after you press the pedal, then the engine will do something. Okay, okay, pelik kan soalan nombor 2, engine tu dekat the plant, but not the engine is the actuator. Okay, so basically Kalau dia kata refer figure A, refer je figure A tu. Kalau tak ada benda lain, engine lah tu. Okay, mungkin roda pun boleh juga, tapi basically roda ni akan digerakkan oleh engine. So it doesn't give you like what are tires here, perkataan tires. So bukan tire lah. Okay, engine is more appropriate. So car body is what?
System.
Plan or process.
Okay, plan or process. Okay. So remember block diagram ni adalah susunan the elements of control system. Okay. So that's why I ask you to identify what are the elements of control system before you draw the block diagram. So it's better if you can identify the elements, then use the elements that you have identified to draw the block diagram. Okay. So the car body is the plan. Okay. Plan or process. Okay, so question B, in your opinion, how can we redesign the system above to make it a closed loop? So name one component to add and then draw the block diagram, redraw the block diagram. So, yes.
Yang soalan A tu output dia apa? Dia tak ada.
Oh, ada output kat sini, silap. So output dia, we have desired speed input. So actual speed pun boleh juga, sorry. So ada output kat situ. So actual speed lah kot. So basically car cruise is about controlling the speed, okay? Okay, thank you. Kalau tidak tak terjawab soalan ni. Okay, question B, how can we redesign? Macam mana nak make it a closed loop system? So to make it closed loop,
Tambah sensor.
yes. So we can add
Tambah speed sensor boleh sir?
boleh. We can add speed sensor. We can add more appropriately we can add tachometer. Tachometer yang dekat dashboard tu the speed sensor lah tu. Okay. Tiba-tiba pandai kereta kan. Add the sensor to measure the actual speed. And then add comparator pun boleh. Add a comparator to calculate error in speed. Okay. And then the question asks you to name the component you want to add. So you kata tadi speed sensor, tachometer, kalau ada lagi saya tak tahu. Okay, speed sensor boleh, tachometer boleh. And then redraw the block diagram. So to redraw, so you have desired speed, and then you have this comparator, and then we have a pedal, or you can add a controller ke a control logic before pedal, but not necessary, tak selalunya perlukan controller. Kadang-kadang dalam kereta kita ada tachometer tu kita sendiri yang akan kawal speed, okay? Kita sendiri akan kawal speed of the car by controlling the push on the pedal. Okay, mungkin kereta zaman dulu tak ada tachometer tu, so macam tekan je speed, tak tahu speed limit berapa, mungkin macam tu kot. Okay. And then pedal, and then engine, and then we have car body, and then actual speed, and then we have speed sensor here. So the important things that this question actually asks is to add a sensor. Okay. And of course, you need to add this comparator when you want to draw a closed loop diagram. And then question C, discuss the advantages of using closed loop system for a car cruise control. So advantages dia boleh refer dalam slide lah. Tapi if you can answer in terms of car cruise control is better. So the advantages is we can maintain the speed of the car even though there is a disturbance or external disturbance that might affect the speed of the car. And tu je lah kot. Okay, we can control the speed of the car despite there is a disturbance that can affect the speed of the car. Okay. And then question D, identify and describe one disturbance that may affect the system. So kalau kereta ni bergerak atas jalan raya, what do you think the disturbance that may affect the speed of the car? What do you think the disturbance? Gangguan yang menyebabkan speed kereta tu sama ada bertambah ke, berkurang ke?
Boleh tak kalau kata
Permukaan
environment?
Okay, environment dulu. Environment tadi kena spesifik lah. Macam tadi kau jawab permukaan jalan. So permukaan jalan tu environment juga, tapi dia spesifik permukaan jalan. So mungkin permukaan jalan yang rata, speed akan jadi lebih laju. Permukaan jalan yang macam kasar, speed akan jadi akan menurun. Ataupun road punya latitude, punya shape ke, okay. Kalau turun bukit akan jadi lebih laju, naik bukit speed akan berkurang. Okay. And then another disturbance may be angin, pengaruh angin. If there is a wind blowing in front towards the car, then the speed will reduce. So you need to increase the speed to maintain let's say 100 km/h for example. So kadang-kadang ada student jawab engine rosak. Engine rosak tu dia memang disturbance tapi dia macam rosak, maksudnya kereta tu rosak, dia bukan speed je yang rosak, dia rosak overall. Okay. So dia macam tak boleh terima lah soalan tu, macam senang je. Disturbance hari kiamat macam tu jawapan, macam tu dah. So it can cause the kereta meletup contohnya. So that is not disturbance. Disturbance ni kita kalau boleh jawab lah yang menyebabkan speed tu bertambah ke berkurang ke. Kalau temperature, disturbance yang menyebabkan temperature tu bertambah ke berkurang ke, bukanlah menyebabkan sistem tu rosak terus. Okay. Selalunya jawapan yang macam engine rosak, tu saya bagi kurang markah. Okay. Selalunya kita orang lecturer akan bagi kurang lah. So kalau jawapan macam road surface, and then you explain sikit how road surface actually affecting the speed, that will be complete lah, because the question asks you to identify and then describe. Okay, describe macam mana disturbance to affect the system. Okay. Okay, so that's it. Any question before we end this lecture?
So sir, for disturbance tu, let's see macam mana, other than kita kata problems atau disturbance yang relate to environment, ada tak anything yang kita boleh relate with the disturbance?
Macam mana tu tak faham.
Okay, contoh tadi kan kita kata apa, surface of the road kan. So technically tu macam kita kata apa, relate to environment punya ni lah. Okay, so ada the environment punya tu, ada tak macam any possible kita kata apa,
possible things. Entahlah, tanya saya tak pandai kereta. Mungkin dia based on how you describe, okay? Let's say you kata tayar pancit terlanggar paku. And then you cakap bila tayar pancit terlanggar paku, walaupun kita tekan pedal laju, speed dia berkurang sebab dia ada geseran between the paku and the road surface. Macam ada bunyi teguk. Mungkin boleh terima, tapi kalau you jawab tayar langgar paku, so pemandu terpaksa bawa perlahan kerana tak nak bagi tayar meletup. Itu bukanlah jawapan. Description tu macam tak ada kaitan dengan speed pun. Macam tu. So it's like how you want to maintain the speed, let's say at 100 km/h. Walaupun ada disturbance, what are the disturbance that can cause the car to not move at 100 km/h? Bukan disebabkan nak berhati-hati ke, ataupun contohnya macam ada lembu melintas terpaksa berhenti. Boleh juga tu, tapi macam kelakar lah jawapan tu, macam tu. Macam road surface tadi macam educated lah jawapan tu. Jawapan macam tayar meletup tu dia kurang educated. Kalau pergi interview kerja ke, bos tanya, bila bagi jawapan macam tu dia pun macam tak nak ambil, macam tu kot. Ke tak menjawab? Ke melalut?
Kira. So kita boleh kata dia based on kita punya imagination ke macam mana?
Dia based on how you describe it. Okay, kalau describe tu macam make sense, okay lah. Kalau describe tu macam lah dia ni tu adalah markah aku sikit je lah, macam tu. It's because the question asks you to describe. Yes.
Kalau kita cakap shape kereta tu as disturbance boleh ke?
Macam tak kot, sebab takkanlah kita nak sebab the car shape is already pre-built, macam memang dah ada macam tu. Contohnya kalau nak bagi dia kurang disturbance, kena tukar shape of the car. Macam tu baik you cakap je beli kereta baru, macam tu lah.
Okay sir, thank you.
So macam environment tadi, macam environment like wind, friction, all of this the controller still can compensate. Okay, contohnya dia boleh measure the speed of the car, and then let's say if you have a controller yang menyebabkan kereta tu automatically drive, then dia boleh kira, okay? Dia boleh kira the difference between the speed. Tapi kalau macam ada shape of the car ke, it's actually memang macam tu dah. Maksudnya the controller tu akan macam dia dah calibrate already lah based on the shape of the car. Tak tahu lah, tak faham kot lantak. Okay, starting this Wednesday kita akan masuk chapter 2, lecture 2. So lecture 2 will be towards calculation lah. Okay. So starting from lecture 2 onwards, this subject becomes heavily towards calculation. Okay. Only lecture 1 yang macam theoretical sikit, macam kena berfikir sikit. Bila involve calculation, it requires you to faham macam maths lah, faham calculation and faham the concept later on. So I hope you boleh ready lah dengan calculation ke, ataupun tengok nota sikit ke. As I said last week, prepare sikit ke 5 minit sebelum kelas, so that you tahu apa benda akan belajar in the next class. Okay. So I think that's it for today's class. You can also start look at your project part 1. So project part 1 is different from last semester. So siapa yang repeat for this semester AC, please be aware that part 1 is different from last semester. So you can have a look at the part 1 project. So maybe the submission may be week 5 or week 6. I will announce later, okay, for part 1. Okay, part 1 out of 5 parts. Okay, so please have a look and bolehlah start buat. Okay, so that's it for today's class. Any question, you can WhatsApp me. Okay, thank you very much. Assalamualaikum.
Thank you, Dr.
Thank you. Alright.
Thank you, sir.
Thank
Thank you,
you.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Sama-sama.
Thank you.